Hello, welcome to today's class. Today we have this radical challenge before us. The question is m equal to the cube root of 3, the plus under it we have the square root of 9 plus m to the power of 3. So we have two radicals here. One, the cube root radical and the square root radical. So how do we simplify this for the value of m that will satisfy this challenge? Let's take a solution. Okay. Now, the first we're going to do here, because the cube root radical is the one at the top here, so we take the cube of both sides of this equation. And so if we do that, this is going to give us our m to the power of 3. This is equal to the cube root of our 3, the plus the square root of 9 plus m to the power of 3. We raise this to the power of 3 also. So we want to apply a simple law in indices, which says if you have your x to the power of your m, then n, this could be written or expressed as x to the power of m plus bracket raised to the power of n. So with this, then we can use this to multiply this. We cancel out, right? So if we cancel out, then we are now left with our m to the power of 3. This is equal to 3 plus the square root of 9 plus m to the power of 3. We move this 3 to make this m here. So moving into the left-hand side will give us m to the power of 3, then minus our 3. This is equal to the square root of our 9 plus m to the power of 3. Okay, so this is a square root radical. So we take the square of both sides this time around. So we raise this to the power of 2. We equally raise this to the power of 2. So with this and this will leave. So let's open up this side of this equation. So we have here means times itself. We use this to multiply itself. Then minus 3, then everything equal to R9, then plus m to the power of 3. Okay, so we use m to the power of 3 to times m to the power of 3. That will give us our m to the power of 6, then minus our 3m to the power of 3, then minus, we use this to times this, our 3m to the power of 3, then minus 3 times minus 3 will give us our plus 9. Everything equal to 9 plus m to the power of 3. So we can sum up these middle terms. So this is going to give us our m to the power of 6, right? Then minus 6m to the power of 3, then plus our 9 equal to 9 plus an m to the power of 3. Now check this out. We're having plus 9 here and we're having plus 9 here. And so this and this will leave. Move this term to this side. This will now give us m to the power of 6 minus 6m to the power of 3. Then minus our m to the power of 3. Everything equal to 0. So this is a 6th degree polynomial equation. But here we are having m to the power of 3 and m to the power of 3. So if we simplify this, we're going to give us our m to the power of 6, then minus, if we subtract this from this, then it will give us minus 7m to the power of 3 equal to 0. So m to the power of 3 is common to these two quantities here. So let's factor out m to the power of 3. So we're going to have here m to the power of 3 into, if we use this to divide this, we are left with our m to the power of 3, then minus, we use this to divide this, so I'm left with just 7, then equal to 0. Then we applied a rule which says that when you have your a times b, this is equal to 0, then it means, or we can say this implies that our a is equal to 0 or b is equal to 0. So if we apply this rule, we can equate this to 0, equate this to 0. So our case 1, we're going to have our m to the power of 3 this is equal to 0. So we have to check if this will actually satisfy the original equation. What is our original equation? Look at it here. If we decide to put 0 here, then we put 0 here, then here is going to give us square root of 9, and the square root of 9 will give us 3. So 3 plus 3 will give us 6. So the cube root of 6 is not equal to 0. And so this solution does not satisfy the equation. And so this one is rejected. Okay. In other words, we call this solution an extraneous solution. So it's rejected. Now let's take our case 2. Our case 2, we take the other expression, which is our m to the power of 3, then minus 7 equal to 0. Move this to this side of the equation. That is going to give us m to the power of 3 equal to positive 7. Here we are having m to the power of 3. So we take the cube root of both sides of this equation. In other words, let's raise this to power of 1 all over 3. We equally raise this to the power of 1 all over 3. So this will leave. We will consider this law here. Then from here, we are now left with our m. Therefore, m is equal to 7 to the power of 1 all over 3. Okay, so this is the value of m that will satisfy the original equation. But we can check if this actually satisfies the equation. So let's take our check here. So let's check. Our equation is m is equal to our cube root of 3, the plus square root of 9 plus m to the power of 3, right? So if we substitute, this is going to give us 7 to the power of 1 all over 3 is equal to the cube root of our 3, the plus the square root of 9, the plus 7 to the power of 1 all over 3, all raised to power 3. So from here, this we cancel up with this. So we are now left with our 7 to the power of 1 all over 3. This is equal to the cube root of our 3, the plus the square root of 9, the plus our 7. So this side will give us our cube root of 3, the plus the square root of 16, because 9 plus 7 will give us 16. Then from here, we now have this to be the cube root of 3 plus 4. If we add 3 to 4, that will give us the cube root of 7, right? Good. So if we have this to be cube root of 7, the cube root of 7 can equally be written as 7 to the power of 1 all over 3. And on this other side, here down, there we also have our 7 to the power of 1 all over 3. So it shows that the answer, which is 7 to the power of 1 all over 3, actually satisfies the original equation. So this brings us to the end of this math class. Drop a comment in the comment section. Until we see you in our next class, keep watching Math Prowess. Bye.